Okay, so I think all of your this is the first time I'm seeing all of you. So just to give you a brief background of what we're gonna do today. So usually how I conduct my classes. Okay, number one, I will go through very briefly on what's the content of this topic first. Okay, then after that we'll go through all the worksheet questions. Okay, then anytime you all need to go toilet, you can just got a text message, got any more is fine. Yeah. Then maybe towards the end, if got some time, I can play couple game. Okay. Okay, I'll exit this group of slides first. So we will use the notes. I hope you all have gone through the notes, or at least like the schools have started on this chapter before lah. Anyway, I think this one from what I know, right, is that lower sec science maybe they will cover a bit. Okay, so I will just go through briefly what we covered in the lecture video. Okay, so the first part of this lesson, we need to know exactly what are the three states of matter. Okay, so three states of matter is the same three states that we learned in primary school. Yeah, so it's your solid, liquid, and gas. Okay, and then what exactly is this kinetic particle theory about, right? Basically telling you that for any type of matter, okay, whether whatever state it is in, solid, liquid, or gas, okay, it is always made up of small particles. Okay, even you and me, right, we are all made up of smaller particles. Okay? So it can be atoms, molecules, or ions. And basically, all these atoms, right, they have some form of kinetic energy. Okay, so kinetic, right, means movement. Yeah, which means they are always moving one no matter what. Okay, all these particles are in constant random motion. Okay, okay. And then we have this particulate model of matter. Basically, it's just to show you, okay, what the particles look like in each of the three different states. Okay, so you can see in the solid state over here, this one. Okay, it's very neatly arranged. All the particles are like super close to one another. There's no place to like make them any closer anymore already. Yeah, so this one is solid. Okay, then liquid state they are a little bit more irregular. Okay, it's so neat, irregular. Okay, but they're still relatively close to one another. Yeah, then for gases is the one where got a lot of space in between. Totally not touching one another. Okay. So you need to be familiar on how to explain, okay, like what is the motion of all the particles in each of the three different states. Okay, so the motion for solid, okay, they look like they cannot move, but actually they are vibrating at their fixed position. So the keyword is vibrate and fixed positions. Okay, must mention this in answer whenever you answer questions. Okay. Then for liquids, basically they also vibrate about the fixed position. That's the first type of movement. The second type of movement is that actually they can slide past one another also. So this is number two. Okay, vibrate and even slide past one another. Steam for gas is move rapidly and randomly in all directions because they are not attached to one another anymore. They are like free already, so they can fly all everywhere. Oh, okay. Then we talk about attraction between particles. We just look at how close they are. The closer the particles are, then the attraction will be stronger. It's like two magnets like that. You bring the magnets further, right? Then they don't really attract each other. You bring them closer, and maybe they will attract already. Ah. So for solid, because they are so close to one another, okay, the attraction is very strong. Okay, liquids is relatively close by also, so it's like it's strong, but not as strong as the one in solid, so we call it strong. Then the gas one is almost don't have one. Okay, very weak. Negligible means almost zero. Or like you can ignore one negligible. Okay, so there's no attraction, they are free. Yeah. Okay, in terms of the arrangement, you can see okay, solid is regular pattern, whereas for liquid and gas is irregular. Yeah, don't have like very fixed, nice pattern. Okay. Then we have the distance between particles. Okay, solid is very closely packed, liquid is close to one another, and then gas is very far. Okay. Then the last two is the shape and the volume. So shape and volume, these two I think is covered in primary school already. So we just recap. And you need to know how to explain using the particular model of metal. So for solid, remember it's fixed volume and fixed shape. Because fixed shape is because all the particles are very closely aligned. They don't move about, they don't slip. So whatever shape it is, it will just be that particular shape. You cannot change for no reason. Okay, so it has its own fixed shape. Okay, then for volume is also you cannot expand it or you cannot contract it because they are already so close to one another, so you cannot expand. Okay, and then because they are so close to one another, so you cannot contract. Then you cannot expand them because their attraction is very strong also, so you cannot like pull them apart. So yeah. Okay, then for liquid, okay, liquid for the shape, right, takes the shape of the container because particles can flow. So when the particles can flow, then they will take the shape of whatever container they're in, like water like that. Okay, so the water will take the shape of the container because they will flow past one another. Okay, but in terms of the volume, it is fixed because it is still relatively close to one another. You cannot expand it, you cannot contract it also. Okay, then lastly for gas, okay, gas is no fixed volume, no fixed shape one. So take the shape of the container, and then it can be compressed, can be expanded also, or expanded. Okay, because now the particles are not attracted to one another, they're free, right? Okay, okay. Then the second part is discussing changes in states. Okay, so the three states between maybe solid and liquid, what do you call this? Okay. So change in state basically is telling you that the first thing is physical change. There's no chemical reaction. You are not forming a new chemical compound. Okay. So it's simply just the same compound but in different state. So it's called a physical change. Okay. In order for the states to change, okay, it involves your thermal energy or rather your heat. Okay, heat energy must either be gained or lost, such that your state change can occur. Okay, so the thermal energy, what is it used for? Is either to break attractive forces, the one that we talked about, the two molecules come together, then they attract one. Okay, either to break it or to reform the attractive forces. Okay, so for processes that gain heat, okay, will be things like your melting. So going from solid to liquid, this one over here. Then you have your evaporation and boiling, so going from liquid to gas. Or you can go directly from solid to gas, which is known as sublimation. Okay, so all these are heat processes that take in heat. Okay, the opposite is processes that lose heat. Okay, so for example, you're freezing, okay, which is from liquid to solid, condensation from gas to liquid, then deposition, which is gas all the way down to solid direct. Yeah, so these terms to be familiar, and you know we need what state to what state. Yeah, and very easy to see on the process. Okay, and then how to explain a change is using kinetic particle. Basically, you need to explain all these things. Okay, so part is you need to tell me first when you're doing something, okay, eating, okay, as the okay, your thermal energy is converted to electron which heat energy. So heat energy converted to kinetic movement. Because just now your particles always moving. Okay, the particles gain kinetic energy. Okay, they will vibrate more. For example, in the solid state, they will vibrate more. Okay, and as they vibrate, temperature of the substance will keep going up. So this is what you see when you heat something up. The temperature is going up. Okay, until you reach the solid's melting or boiling point, it's melting point or liquid's boiling point. Okay, then what will happen? So, for example, when looking at melting, so melting is solid. So now, right, we continue to heat this solid up at its melting point. Okay, instead of converting the thermal energy to kinetic energy, okay, the thermal energy, right, now is going to use to to overcome the attractive forces. Because imagine you try and pull two things that are threaded together, you need to pull them apart, you need to pull in energy also. Okay, so instead of heating the thing up further, you use the energy to overcome the attractive forces. Okay, then therefore this one results in a state change, for example, from solid to liquid. So if let's say, okay, solid, we know that attraction is very strong and particles cannot snap past one another. Then for liquid, then they can snap past one another because the attraction forces is not so strong. Yeah. Okay, and then take note of this part, during state change, right? No temperature change is observed. No increase in temperature is observed. Okay, no temperature increase change is observed because all the energy is not used to convert to kinetic. It is used to overcome attractive forces. You're actually not heating up the subject, not heating up the object. If the once the state change is completely melt finish already, then whatever additional energy that I supply will then continue to be converted to kinetic energy, then further result in a increase in temperature. Okay, so this is how you use state particle theory to explain your state change. Yeah.
Could you repeat that? You were lagging a
Okay,
bit.
so the whole side is it or what?
Yeah, the whole site. Is it okay if you repeat? You were lagging a bit just now.
Okay, now is it better?
Yeah. Should be.
Now better. Okay. So to go back, basically the key point is to tell you when you heat a substance, okay, you are supplying thermal energy, which is heat energy. Okay, and the heat energy will be converted to another form of energy, which is kinetic energy, which is on movement of the particles. So what happens is when you heat up particles, the particles move more, they vibrate more. Yeah, then when they vibrate more, this results in an increase in the temperature of the substance. Okay. Then once you reach the melting point, let's say of a solid, okay, melting point means they are ready to change state already. Then any additional energy that you supply, right, is not going to be converted to kinetic energy. It will be converted, or rather, it will be used to overcome the attractive forces, the solid. So remember, solid, the attractive forces are very strong, and all the particles, they cannot move about freely, right? They can only vibrate in the fixed position. Okay, so it's used to overcome such that it reaches a point where your particles can slide past one another, which is known as your liquid state. Yeah, so this is your state change, for example, melting. Okay, then because of this, right, we are not actually increasing the kinetic energy of the thing, right, during state change. Therefore, there is no increase in temperature. There is no increase in temperature. Your temperature will remain constant during the entire change of state, from start of melting to end of melting. Then finally, at the end, once you melt finish already, all become liquid already, then it don't need to change state anymore, ma. You will just continue to heat up the liquid, then it will continue to further increase the temperature. But the thermal energy will continue to convert to kinetic, your particles to more something in temperature go up. See, so that is just what the slide is telling you about. Yeah. Okay, then for this slide is basically the opposite because we're talking about cooling down. So it's the same thing. I will go through very quickly. Okay, instead of thermal energy being supplied, right? I want to lose the thermal energy to the environment. That's how the thing cools down. Yeah, so energy to the environment. Yeah. So then basically now instead of, oh no, connection is unstable. Okay. Okay, so now instead of heating it up, okay, I'm going to convert my kinetic to thermal energy instead, then lose it to the environment. So when particles lose kinetic energy, the temperature drop. It's already temperature drop, temperature drop. Okay, then once you reach, let's say your freezing point, for example, okay, so I'm going from liquid to solid state already. Okay, then basically now instead of losing the thermal energy, losing kinetic energy to the surrounding, right? Okay, all the thermal energy lost, right, is used to form back instead of break, right? Now it's formed back the attractive forces. Okay, so all your particles become very, very neatly arranged, go back to the solid state that arrangement. Okay, then no decrease in temperature is observed, so it's the same thing. Okay, during state change, no change in temperature observed. Then finally, once the freezing is completed, okay, all becomes solid already. And your additional thermal energy that's being lost, then it will continue to decrease the temperature again. Okay, okay. Then we have heating and cooling curves. So heating curve basically is like a graph to represent what we learned about the heating process and then melting and boiling as well. So on heating curve, just take note, okay, y-axis here is the vertical axis. This one is our temperature. This is temperature. And then the x-axis is of course the time. So time is when I keep hitting across time. Okay, so over here you will see that it looks like a staircase. Okay, basically need to know, okay, from A to B. So A to B is this part now. This part. Okay, this is our regular heating. Why? Because I can see temperature going up. When temperature going up, I know that there is no state change occurring. No state change. It is the same state. So this whole thing here is solid phase. It's not melting yet. Okay, so what happens here? The particles gain kinetic energy, temperature go up. Then we go on to the next one, which is B here now. How to know where